Today I want to talk about microservices and what do I have with microservices at all. So I work in the company where we developed microservices for 3 years from the very beginning of this company, and I no longer work there. But anyways, I'm Jan Filipowski, full stack developer at Format.com. Here's my blog and Twitter handle. So first of all, what are microservices? Those are, this is the definition of microservices architecture, which is a system of suite of services that are independently deployed, small modular. Oh, what is it? Not my Mac. Okay. So independently deployed, small modular, and in separate processes. And here's what I want to talk about, like the plan of this presentation. So first of all, I want to tell you about this approach from the top to the bottom, just from the really high-level architecture in the organization. And then there will be also ongoing example of some failed project you can imagine in this architecture. So I have 2 laptops, rich. So example details. We have a micro company, which is like less than 10 employees at all. And it is a blog that is already existing, like super awesome blog with some lifestyle shit. And there's an e-commerce that sells stuff. And the blog is already existing, but the e-commerce will be created while maintaining this whole project. And the team decided to use microservices architecture. First of all, when you want to think about the architecture at all, like not only the microservices pattern, but also any other, you have to place it in the organization. You have to think how big the company is and how many departments it has. What's the stage of this company? Is it early stage or some later, like big corporations? You also have to think who will develop and maintain microservices. If you decide to just have one team of developers and 20 microservices, it may end up with really huge fuck up. Because this is the problem of ownership and knowledge about them. Like, when you have 20 programs that have different language used in it, not the programming language, but in terms of domain, then you have really huge problem if you want to dig in as newly introduced developer. So in our failure case, it will be a micro company, as I said, that has some customer support, which is the nice name for the sales. Some accounting, because you have to deal with your country and government. And IT, because we have developers, right? And we want to develop some stuff. IT is small, like for developers. There's a simple rule that each microservice should be maintained and owned by at least 2 owners. Like, you know, just to, if one of them crash in the plane or decide to work somewhere else, which is less probable, then yeah. And knowledge sharing, you can use some microservices, but you can also use GitHub as a portfolio stuff. Awful voice. Sound. So this is still architecture. Yeah, we can't avoid some hard decisions. We can't live in the fluid world where there is no hardened part. So you have to think about 2 things that are most important in microservices, which are communication, how microservices will talk to each other and talk to the world, and deployment platform. I would call it platform, but deployment means like it's clearer. Okay, so about communication. First of all, you have to think about which channel will you use. HTTP, message queue, will it be async or sync? This is a really hard decision. And will you use messages or events? So messages, you can think about messages as just method calls in remote world. And events are like facts that you can gather from other microservices that you will use to introduce some interaction in your microservice. You have to think about protocol and protocol versioning because the world isn't static. So you always will have some triggers for change of this protocol. In protocol, you can think of, I don't know, JSON API or SOAP or whatever. You have to think about routing, so how microservices will discover each other and how they will route their messages or events to each other. You have to think about reliability policy, so how sure you want to be about delivery of given message or event. And there are two possibilities, like at least once or at most once. And message contracts, because in distributed world, you have to think about not only your microservice, but also other microservices that use your microservice or communicate with it. So to not break whole functionality because of some small change in the protocol used, you have to use some message contracts or not, and that's the decision for you. Okay. Now the deployment platform. So this is simple. Like, how will you deploy your microservice? Will it be the process, like process in bigger instance server, or will it be container? So in our case, in communication, we decided to use RabbitMQ because it's easy out of the box, just to start with it. It will be async and it will use events. So every change in the system will be published on some RabbitMQ queues, and other microservices will just get them from that. Queue will be created, so this is queue per event type is the routing idea. So every single event type, like post published or item bought, will be published on separate queue on RabbitMQ. And for every change in the protocol of those events, new queue will be created. So you will have versioned queues in RabbitMQ. About the, wait a second. About reliability, I decided to use at least once delivery, and worth considering in this case would be a hybrid, Jesus, how to say it in English, hybrid, which will use some async and sync protocol. Like, think about HTTP between some really fast things. You know, you want to send S3 files to S3 in real time, and then you can use sync way of communication and HTTP or RabbitMQ for this. In terms of platform, let's not complicate it too much, and it will be just Docker and Docker Swarm. And there are other options are high-level virtualization like Vagrant or some AWS stuff. Other containers, Kubernetes, maybe plain KVM or process. Process is the most shitty one. So right now we decided how to deploy our application. We decided how to manage stuff in our organization, but we have to also think how will we create new microservices? What will be the driver for this splitting stuff? So first idea is to use by subdomain approach, which you may think about subdomain as DDD concept. So do you know DDD? Like who understood what I told you about? Okay, so in DDD, you think about your corporation, your company, not as a single domain that can cover linguistically your whole company. Like marketing won't talk to you in same terms as customer support, because marketing want to grow sales and customer support want to have things solved. So every single department or every single bigger department has its own language, which creates subdomain. And this subdomain may be a good environment to create microservices, because you will have the same vocabulary within a single microservice. And the other way to split microservices, and I cannot think of anything else, is computation constraints. So think about some huge ETL jobs that have to be handled distributed, and each of these ETL is like pipe to something else, and then you just see microservices there, because yeah, this is the problem that can blah blah blah. Okay, so the second question is when to split microservices. So if you have two big microservices, so if it has more than one responsibility or cover more than one subdomain, you want to split it to two microservices or more. If you work with huge monolith and it's really hard to maintain, you also can split it, and it's a really good way for big companies to introduce new features that won't collide with your monolith. And the hardest part, or the hardest approach, would be splitting from the very beginning. If you have really new application, new system, and you don't know where the boundaries are, it's really hard to split it up front, because you will have to change those boundaries really often, and there will be too much effort to maintain it. And the example here is we just decided to introduce two our own microservices, which are blog and shop, but there will be also warehousing, accounting, and live chat that will be handled by some third-party apps, which can also be treated as microservices, because they have a single responsibility. About the development, so in development process, the most important part is delivering microservices continuously. So continuous delivery is the most important part. By this I mean you cannot deliver two microservices in the same time if it's the requirement. The good approach is to deliver every single microservice independently. You can also, in this environment, use polyglot programming, so you can use many programming languages, and this should be applied with the same rule as for ownership. So there should be at least two developers that know the language that it's used and can maintain it. And to make development of new microservice easier, and this is also like a really important part, is having microservice template. So you don't want to be afraid of creating new microservice because it's too hard, because then you just won't create any of them. So you need some easy way to create new microservice. So operations and maintenance, so the lowest level of microservice architecture. First of all, oh, do you see? Yeah. So first of all, you have to think about every single part of this maintenance part or infra part as super generic. It cannot be something created only for single microservice that you have to copy and paste, because it will just make too much effort to introduce new microservice and to maintain it. So for every microservice, you probably will use the same way to deploy it, to configure it, and other infra stuff. So as things that you have to think about are the service discovery, which is the way you will route your traffic to correct microservice. Server provisioning, you have to think about your microservices architecture system as distributed one. So you want to introduce new swarm nodes or any other nodes of your containerization software as something that should be quite generic and easy to introduce. Configuration management, so something like Chef or Ansible to create correct setup in newly provisioned instance. Logging, monitoring and self-healing and auto-scaling. So in our example, for the service discovery, we can use Docker Swarm because it already handles all the stuff that we want. But you can also think about console or etcd plus some proxy server like Nginx or Haproxy. For server provisioning, we used Terraform, and it could be CloudFormation or any other infrastructure as a code. Configuration management, so here's a Chef. Logging is a Elasticsearch, Logstash, Kibana stack, but it also can be Graylog. Monitoring, Datadog, Zabbix, ELK, error notifications, Sentry or Airbrake, self-healing, Docker Swarm or Monit, Runit, Console, auto-scaling, still Docker Swarm, but also some AWS stuff or Kubernetes. So let's think about this given project, but also some other projects that you can think of when you want to use microservices architecture. So first of all, how many decisions had to be made at the very beginning that are quite, that will have big impact on this architecture? So there were like 10 of them. So communication stuff, platform stuff, and tooling stuff, and at least 15 tools just to handle infra, and some domain microservices like 5. So as you can see, there were too much infra for small problem. Like we wanted just 2 programs to exist, but we end up with really huge infrastructure level that had to be maintained. There is a freedom of language that you can pick to develop each of microservices, but each of them has maintenance cost. And if you think about polyglot databases, it's even much more. Like, you don't want to crash your database of any form. And as you can also see, it was focused on the tools and not on the domain problem. So it's a really awesome playground for us developers, but it's not so valuable for our customer. And to make it better, like where it should be applied, you can think of big companies where they have many departments with many developers that can communicate with each department separately. So maybe be part of each of departments. And then it can give real freedom because every single team can develop what they just want and need. And some chief architect can decide about those high-level stuff. And it also can be applied in matured systems that are hard to maintain and has already many of those tools introduced as a monolith. So the best thing is continuously deployed monolith with some tangled code that shouldn't be easy to work with as a monolith. And that's all, but I'm open to questions if any one of you have. Yeah.
Okay, thanks for the talk. I wanted to ask if you have considered using something like a race engine in which you don't need to separate a microservice up front, but you need to use the same language and tooling and stuff.
Okay, so just to be super honest, this example that I showed you was not completely out of the domain that we used, our microservice approach. And in some of our problems were split to microservices because of the computation constraints. So we just couldn't have a Rails application that would do the stuff, right? Because we had to have many IPs or many computation resources. So in this case, no, but probably it would be worth considering if I would want to modularize our application. Okay, so thank you very much.